For this problem, a rocket is flying into space for 30 seconds. The initial velocity of the rocket is 75 meters per second, and the mass is 425 kilograms. To find the impulse of this rocket engine, you are going to need to use the area under the curve of this force time graph. Since it's a triangle, you use the area equals 1/2 times base times height. When you plug in the base and height of this graph right here, then you will get 15,000 newtons per second, and that will act as our impulse value for this problem. Remember that impulse equals the change in momentum, so when you solve for J equals change in P, which is impulse equals change in momentum, you can break this down into the mass of the final mass times the final velocity minus the mass of the initial times the velocity of the initial. So when you plug in your values and rearrange the equation, you can set it up so that your final velocity is equal to the impulse plus the mass of the rocket times the mass or the velocity of the rocket, the initial velocity. And you divide that by the mass of the rocket. Your final velocity will be 110.3 meters per second. And you need to remember that since the rocket is being constantly launched into space, the fastest speed will be at 30 seconds because it's getting faster and faster as time goes on.